Hi, welcome back to SACE Mathematical Methods. So today we will go into the idea of function transformation. So this is our topic today. We will look at how function transforms when you have some coordinate transformation. So the easiest way for us to study function transformation is actually look at, for example, if you have a circle. So let's begin with the y direction first. So let's say the original point over here has coordinate x, y, and you sort of elong it on your y direction. So it means that this point x, y will move up. So let's say after you sort of like stretch it in the y direction, the new coordinate is what we call as the x prime and y prime. So we'll look at the relationship between x prime and x, y prime and y, to sort of like study the effects of functional transformation. So as you can see, if you just stretch in y direction, basically your x does not move, right? So it means that your x prime is equals to x. So now if let's say your stretch factor is a, then your y prime will be a times your original coordinate y. Okay, so we also let y equals to f of x. So we sort of try to study the relationship between coordinate transformation and how it affects the outcome of your function. Alright, so in this case we know that x prime equals to x and your y prime will be equals to the stretch factor a times the y, and we also know that y equals to fx, so this is a times f of x. So this is the first transformation that we study. So now let's look at the second one, whereby we still have the circle, and this is the point. You know what? Let's say this is the point. So let's say this point is xy as usual. So now okay, I probably have to draw this bigger. Okay, let's put this point as x and y. So now we try to compress this particular circle in the y direction. So you compress it going down. So of course, when you sort of try to press your circle, compress it inwards, it will become an oval like that. So this particular point xy, so now it will be transformed into the new coordinate x prime and y prime. So what will be the relationship? In terms of the x, you are still the same. Let's say the compression factor is 1 over a. Then your y prime will become uh, 1 over a y. So as usual, we let y equals to fx. So now coming from here, you notice that x prime is still your x, y prime is 1 over a y, which is 1 over a fx. Okay, so this is the compressed factor. So the first two transformation is along the y direction. So now we look at the x direction. So if let's say, okay, let's write down the transformation over here. So for the first one, you can say that this is a stretch in y direction by a factor of a. So in this case, your a has to be greater than 1. Whereas over here, this will be a compression in y direction by a factor of 1 over a. So in this case, because I already did the reciprocal, so a of course still have to be greater than 1. So in this case, it depends on really how you memorize the equation or how you memorize the transformation. So we will do a final conclusion at the very end. So no worries. So for now, you just sort of like take this as it is. So the third transformation will be along the x direction. So let's say you have a circle. So if you stretch along the x direction, it will become an oval like this. So your original point here is xy, for example. So it will be being stretched outwards and it will reach x prime, y prime. So let's say this stretch factor in the direction of in the direction of x is b. So x prime is b multiplied by x. Your y prime stays the same, which is y. So we still let y equals to fx. And now x prime equals to b multiplied by x. Y prime equals to y. So here's something that you need to be careful about, because your y is in terms of is a function of x. So you sort of need to write this particular function in terms of x prime. So how would you do it? Basically, from this particular equation, you can write x equals to 1 over b of x prime. So then over here, your y prime will be equals to 1 over b x prime. So the reason why we don't need to do this in the first and second case is because x prime is equals to x. So technically speaking, this is also equals to 1 over a times x prime. That's why we don't need to do it. But in terms of your x direction, remember that you have to do it. So it means that if let's say your So if let's say you found this particular form of equation whereby there is this 1 over b term here and b is greater than 1, then so this particular transformation, we call this a stretch in x direction by a factor of, so here you need to be careful. So you need to always remember that this is being reciprocal. B. So remember this particular form because later on it will get confused. So the fourth type, which is compression in the x direction. So let's say this is x and y. You try to compress it. So this is still by a factor of 1 over b. And after your compression, this is x prime, y prime. So as usual, we know that this is 1 over b x and y prime will be equals to y. So we still know that y equals to fx. So first, x prime equals to 1 over b x. So it means that x will be b multiplied with x prime, right? So here I did the transformation as beforehand. So y prime equals to y equals to fx. So this is also equals to f b multiplied with x prime. So if you see this particular scenario, this is a compression in x direction by a factor of 1 over b. Provided, of course, your b is greater than 1. So over here is the same thing, b is greater than 1. So after the stretch and compression, let's look at translation. So translation is relatively easier. Let's say this is your point here, x, y. If you move up by d units, then what you will get is x prime, y prime equals to, so if you just move up, your x prime does not change, which is your x. Y prime will be y plus d. If you move down, so that particular unit will be minus d. So your x prime, y prime will be x, y minus d. So from here, if let's say your y is still fx, so what happens to your function is that your x prime does not change. Your y prime will be y plus or minus d, depending on whether you move up or move down. If you move up, it is plus. If you move down, it is minus. So this will be fx plus or minus d. So in this case, this will be either you move up or you move down by d units. Let's look at the translation of left and right. So if you have a point over here, x, y, and you either move to the left or to the right. So if you move to the right, it will be plus c unit. This will be minus c unit. So what will be this particular point, for example? This will be x plus c, y. So over here, this should be x minus c, y. Alright? So as usual, y is equals to fx, and x prime is equals to x plus or minus c. That depends on whether you move left or right. So this is also where the scenario is a bit difficult to follow, because you need to, as usual, you need to change your x into x prime coordinates. So what would be the case? It will be x is equals to x prime minus plus c. So when you move to the right, it's actually minus in terms of the x prime coordinates. If you move to the left, it is plus in terms of the x prime coordinates. So then we know that y prime equals to y equals to f of x, and this is f x prime minus plus c. So this is move, when it is minus, you move right. When it is plus, you move left by c units. So number 7, reflections. If you reflect on your x axis, so originally it is x, y, you reflect through your x axis, so this will be x prime, y prime. So reflection means that the distance over here is the same as the distance over here. So it also means that your x coordinates does not change. So x prime equals to x. The y prime will be the minus of your original coordinate y. So as usual, y equals to fx. So x does not change. X prime equals to x. So y prime equals to minus of y, which is the minus of fx. So this is what we call as the reflection on your x-axis. So now reflection on your y-axis. So this is your x, this is your y. So let's say originally you have xy over here. So you reflect on your y-axis. So this will be x prime, y prime. So in this case, your x prime will become minus x. Y prime still the same, alright? So we still keep y equals to fx. So over here, x prime equals to minus x, or x will be minus x prime. Y prime equals to y equals to f of x. So you substitute inside, it will become minus x prime. So of course, we have the 9 transformation, which is the inverse function. So whenever you have a reflection on y equals to x, that means you are performing you are finding the inverse function, basically. So now let's try to conclude. If your original function is y equals to fx, then you can sort of like see that you have this following possibilities. So y prime equals to a f b x plus c plus d. So let's look at the effect of each of the component one by one. So the first one, if your a is greater than 1, so if your a is greater than 1, so it means that your function has undergone the stretch in y direction by a factor of a. Okay? So you can also say that this is a compression in y direction by a factor of its reciprocal, which is 1 over a. So if your a is between 0 and 1, this will be a compression in y direction by a factor of 1 over a. You can also say that this is a stretch in y direction by a factor of a. So the third case, when a is negative, so this is a reflection about the x-axis. So that's everything about this particular constant a. So now let's look at constant b. If b is greater than 1, then this is actually a compress in the x direction by a factor of b. You can also say that this is a stretch in x direction by a factor of 1 over b. So if b is between 0 and 1, so this is a stretch in x direction by a factor of 1 over b. Or you can say that this is a compress in x direction by a factor of b. So of course, if b is equals to -1, then this is a reflection about the y-axis. So now let's look at C. If C is greater than 0, so C is inside the function. It means that you move to the left by C units. If C is smaller than 0, then you move to the right by C units. So if it is D is outside of the function. So if D is greater than 0, then this is moved up by D units. If D is smaller than 0, then you move down by D units. So for example, if you look at y equals to 1 over 2 f2x, so you can immediately tell what kind of transformation. Okay, let's say your original function is y equals to fx, and you transform into y prime equals to 1 over 2 f2x. So what kind of transformation that it went through? The first one would be compress in y direction by a factor of 2. So notice that over here a is 1 over 2. So when you refer to this particular table, so 1 over 2 is case number 2. So if you use the word compress, then basically you have to reciprocal your value, which is why you get 2. So your b is equals to 2. So according to this particular table, b equals to 2 is case 4, b greater than 1. So when you write down the transformation, this will be a compression in the x direction by a factor of 2. So in this case, these two transformation, because one involves your x direction, one involves your y direction, the transformation order does not matter. You can do the x one first, and then you do the y one first. You can do the x one first, and then you do the y one later, or you can do the y first, like what I did, and then x later. The reason why I go through all these cases is because some of the transformation, they do not actually commute. So especially when those transformation involves a specific direction, like for example, if you stretch in y direction by some factors, and then you move up by some units, it does not equal to when you move out and then you stretch. So let's look at one example. So if let's say your original function is fx, and the first transformation is stretch in y direction by a factor of 2, and then you move down by 2 units. So both actions involve the y direction, so you need to be careful in this case. So let's look at what happens when you perform number 1 and then you perform number 2 versus when you perform number 2 then you perform number 1. So originally you have y equals to fx. After you go through the first transformation, you would get 2fx because it's a stretch in y direction. Then after you perform the second transformation, you move down by 2 units. So you minus 2. So this is your outcome if you do 1 first and then you do 2 later. So what happens when you do 2 first and then you do 1 later? So you start with y equals to fx. After you do number 2 first, you would get fx minus 2. Then you do number 1. So remember that for number 1, when you stretch it, you have to multiply the whole thing. So this will be 2 multiplied with fx minus 2. That will be 2fx minus 4. Okay? So you can see the difference in this particular case. So what I would stress in this particular scenario is you should be very careful about the x direction version. So let's look at one more example on the x direction version. So you still begin with y equals to fx, and then what you would do is to stretch in x direction by a factor of 2, and then you move left by 2 units. So this time you cannot start directly like this. The reason why I can start this particular example, the reason why I can directly write this is because your transformation involves y. So you start from y and then you go from y prime, and then let's say you go to y double prime because you have 2 transformation. So for this time, what you would need to do is to start from x. So let's say if I begin with the first transformation. So after the first transformation, the new coordinate is what I would call as x prime. And you stretch it by a factor of 2. So you get 2x. So over here, remember to write down what is x in terms of x prime. So it will be x prime over 2. Then you go through the second transformation. So let's denote this as x double prime. And remember that your second transformation depends on x prime, not depend on x. So you move left by 2 units. Move left by 2 units. So you have x prime. You move left, so you minus 2. So it means that your x prime is x double prime plus 2. And your x prime by itself is 2x. Okay? So 2x equals to x double prime plus 2. X will be 1 over 2 x double prime plus 1. So in the end, what is your final equation? The final equation is actually y equals to f 1 over 2 x plus 1. Of course, you can write x double prime in this case, but your y also have to be double prime because you undergo 2 sets of transformation. It's just that those transformation involves your x direction. So now let's look at what happens when you perform the second one first. So you move left by 2 units. It will be equals to x minus 2. So then your x will be x prime plus 2. Then you do the first action, which is stretched by a factor of 2. So x double prime will be 2x prime. So now it's a matter of converting back to x. So x double prime will be equals to 2 times x minus 2. So 1 over 2 x double prime will be equals to x minus 2, or you can just move this like this. So in the end, your function y double prime will be f 1 over 2 x double prime plus 2. So obviously these two results are different. So the reason why I go through all this is because you need to know exactly how this two transformation works in terms of the x and in terms of your y. So if let's say you have originally y equals to sine, sorry that I have not really introduced what is a sine function, but let's assume that there is this function which is a sine function, and you transform this into sine 1 over 2 x plus 2. So you need to be mindful about the whole transformation over here, because from our previous example, so when you have 1 over 2x plus 2, basically what you will need to do is to do the translation first, and then you do the stretch later. So if you want to write down the transformation, the first one has to be the translation. So you need to move left by 2 units. Then you stretch in the x direction by a factor of 2. So if you follow this rule, then in general you won't make any mistakes, because the number over here, 1/2, correspond directly to your stretch factor, and then this particular number correspond directly to this particular value. If you follow exactly this particular order, but that doesn't mean that you cannot do it in the other way around. You can always do this. So this is also possible. You can stretch first. So let's write this as 3 so that you don't confuse. So in this case, your stretch factor is still the same, but when you move to the left, you need to be slightly careful, because as you can see here, it is 1. So you actually need to move left in a sense more. So let's say we move left by 4 units, which is double of your stretch factor. So let's see whether if you follow 3 and then 4, whether or not you would get to the final form of the question. So let's say you have y equals to sine, let's begin with x. After you've gone through the third transformation, so x prime will be equals to 2x, or x is x prime over 2. Then you go through the fourth transformation, so your x double prime will be equals to your x prime minus 4, and your x prime is 2x. So x will be x double prime over 2 plus 2. So finally you substitute this particular value inside. So your y equals to sine x double prime over 2 plus 2, which is exactly what the question asks. So if you don't want to confuse yourself, for the x direction specifically, do the translation first and then do the stretch or compress. If you were to do the stretch first and then do the translation later, remember that the translation has to multiply with your stretch factor. So it won't be the same number. But if you do the translation first and then you do the stretch factor, those numbers will keep the same. So this is the main confusion for the x direction part. For the y direction, is pretty straightforward. Okay, so I think that's all for today's video. Thank you.